In the blink of an eye, we're diving deep into the mysteries of the ocean, soaring to the farthest reaches of the cosmos, tracing the ancient steps of the pyramids and traversing the vast continents of our world. Welcome to your journey through science, space, and the wonders that surround us. From the darkest depths to the brightest stars, we unveil secrets, shatter myths, and ignite curiosity. Here we don't just observe the world, we discover it. We don't just learn, we explore. We don't just dream, we question. If you thirst for knowledge and crave adventure, you've found your haven. Immerse yourself in the marvels of the universe, right here, right now. So, don't just pass by, join us, subscribe, engage, be a part of this extraordinary journey, because the wonders of the world are waiting, and the journey, it's just beginning. Is humanity the only intelligent life in the cosmos, or do alien civilizations exist beyond our blue planet? This question has been a subject of widespread speculation, impassioned debate, and endless pontification that has spanned across centuries. As we raise our eyes to the infinite expanse of celestial bodies that envelop the nocturnal heavens, the idea that we are the only sentient beings in this limitless cosmos seems increasingly unlikely. An infinite number of stars, each potentially encircled by planets, each of these planetary bodies potentially teeming with life. The sheer infinity of it all is a notion that dazzles and mystifies the mind. Each twinkling star in the sky could be a sun-nurturing life on its orbiting planets, each planet a potential stage for the drama of life to unfold, each life an opportunity for intelligence to flourish. This is a concept that both bewilders and intrigues us. As we set out on this journey, into the cosmic unknown, we first need to comprehend the staggering vastness of the cosmos, a universe so immense and intricate that it defies human understanding. Scientists approximate the universe to be home to nearly 2 trillion galaxies, each one housing billions, possibly trillions, of stars. Each star could be orbited by countless planets, some of which could be potential cradles of life. Our understanding of the cosmos expands through theoretical frameworks, mathematical models, scientific postulations, and philosophical reflections. One such model that deserves mention is the Drake equation. Conceived by the American astronomer and astrophysicist Frank Drake in 1961, this equation represents a mathematical endeavor to estimate the potential number of intelligent civilizations that might exist within our Milky Way galaxy alone. The equation factors in variables like the rate of star formation, the fraction of stars that possess planetary systems, the proportion of these planets on which life could form, and finally the chance that this life could evolve into intelligent beings. Yet, despite this equation suggesting a high probability of extraterrestrial life, our attempts at establishing contact with such life forms have so far been met with silence. This leads us to a profound paradox known as the Fermi Paradox, named after the physicist Enrico Fermi. This paradox points out the contradiction between the seemingly high likelihood of extraterrestrial life suggested by the Drake equation and the lack of any contact or evidence supporting the existence of such life. Many theories have been proposed to explain this paradox. One of them is the idea of a great filter, a hypothetical barrier or a series of barriers that prevent civilizations from reaching an advanced stage of development. Could it be that most life forms meet their untimely extinction before they can attain the technological advancement necessary for interstellar communication? The zoo hypothesis offers another explanation, suggesting that we are intentionally being left alone, observed from afar by advanced alien species who have adopted a policy of non-interference. Perhaps we are like animals in a zoo, observed from a safe distance by superior beings, awaiting the day when we are ready for contact. Meanwhile, the rare Earth hypothesis argues that the conditions required for life, as we understand it, are exceptionally rare in the universe. Despite the almost infinite number of stars and planets, the hypothesis argues that the specific conditions necessary for life are seldom met. Our search for extraterrestrial life is not limited to these theories. We also hunt for exoplanets, planets orbiting stars other than our sun. Through the use of advanced technology, we have identified over 4,000 exoplanets to date, each potentially a new world teeming with life. In our tireless pursuit of alien life, we search for biosignatures, indicators of life as we comprehend it, such as the presence of specific gases like oxygen in a planet's atmosphere. While finding a biosignature doesn't guarantee the existence of life, it significantly increases the likelihood. Then there is the search for extraterrestrial intelligence, or SETI, which uses scientific techniques to listen for signals from deep space, possibly sent by extraterrestrial civilizations. Yet, receiving a signal would pose another challenge, deciphering it and understanding the language or code in which it's sent. In this quest for answers about alien life, we also delve deeper into our understanding of what it means to be human. Could there exist life forms radically different from us? Life as we don't yet know or understand it? This query forces us to confront our own existence, our place in the universe, and our understanding of life itself. The quest to answer this question takes us on a cosmic journey, from the mathematical probabilities of the Drake equation to the enigmatic silence of the Fermi Paradox. As we embark on this journey, remember, we're not just seeking alien life, we're exploring what it means to be human in a potentially infinite universe. Imagine a simple equation that could estimate the number of intelligent civilizations in our galaxy. Welcome to the world of the Drake equation. This mathematical formula, conceived by astrophysicist Frank Drake in the early 1960s, is not just a calculation, it's a conversation starter, sparking debates and fueling our curiosity about the cosmos. It's the beginning of a quest, an adventure into the unknown. The Drake equation, in its fundamental form, is a series of factors multiplied together. It begins with the rate of star formation within the boundaries of vast galaxy, considering the multitude of stars that twinkle in the night sky, those countless bright spots that have fascinated humans since the dawn of time. It then moves on to the fraction of these stars that have planetary systems, those celestial bodies rotating around their own suns, each a potential cradle of life. Next, it transitions to the number of planets that could potentially support life. This is where the equation becomes captivating, as it plunges into the realm of the unknown. The hypothesis of habitable worlds, places where life as we know it could thrive, stretches our minds beyond the confines of our own blue planet. The equation then ponders over the fraction of these planets where life could evolve into intelligent beings. It's a thought that has stoked our collective imaginations, from ancient philosophers to modern astrophysicists. It's the spark that has ignited countless science fiction stories and fueled the drive for space exploration. The lifespan of such civilizations is the next consideration. This is where the Drake equation may lead to sobering conclusions. If we assume the lifespan of a technologically advanced civilization is short, perhaps just a few centuries, the equation forecasts a desolate universe. But if we are optimistic and imagine civilizations that endure for tens of thousands of years, the possibilities change. The Milky Way could be teeming with life, an orchestra of civilizations, each playing their own cosmic symphony. Furthermore, the equation considers the fraction of life that could develop a technology that releases detectable signs of their existence into space. It's a thought that prompts us to look up at the stars and wonder if somewhere out there, another civilization is doing the same. Throughout this entire process, what makes the Drake equation so intriguing and at times controversial is the sheer range of possibilities it presents. Each factor in the equation is a variable, a value that can be tweaked and adjusted. Depending on the values you choose, the final tally of civilizations can swing wildly from a solitary existence to a cosmic metropolis teeming with life. Our understanding of where life can thrive has expanded vastly. Once we thought life needed conditions just like Earth. Now we know life is tenacious, possibly thriving on moons, in the acidic clouds of Venus, or in the icy oceans of Europa. The Drake equation is more than just numbers and variables. It's a reflection of our current understanding of the universe and our place within it. It's a tool that helps us ponder the question, are we alone? And yet, the Drake equation is not an answer, but a question. It doesn't tell us how many civilizations are out there. It asks us, what do you think? How alone do you think we are? The Drake equation gives us a glimpse of the immense possibilities, yet it's only one piece of the cosmic puzzle. If there are potentially millions of civilizations out there, why haven't we heard from them? This question has baffled humanity for generations, leading our scientists and philosophers to explore the depths of a cosmic riddle known as the Fermi Paradox. This paradox, named after its progenitor, the renowned physicist Enrico Fermi, confronts us with an unsettling paradox. On one hand, we have the statistical likelihood of extraterrestrial life. On the other, we are faced with a deafening silence from the cosmos, a seemingly contradictory state of affairs that begs for an explanation. To wholly grasp the enigma that Fermi Paradox presents, one must visualize the Milky Way not as a lifeless expanse of space, but rather as a teeming metropolis. Each star, a house; each planet, a potential habitat teeming with life. The sheer magnitude of this galactic city makes the notion of Earth being the sole inhabited house not just outlandish, but almost implausible. Yet, the question remains, why the silence? Various theories have been proposed in an attempt to respond to this perplexing query. The first among these is the Great Filter hypothesis. This theory posits that life's evolution is not as straightforward as we might believe. Instead, it suggests the existence of a formidable barrier or filter that life forms must transcend to evolve, a hurdle that could range from surviving a catastrophic event like a nuclear war to adapting to a planet's drastically changing climate. The terrifying implication of this theory is that if this filter looms in our future, humanity might yet have to face an existential challenge that could potentially wipe us out. Another intriguing theory is the zoo hypothesis. This theory paints a rather disconcerting picture of Earth and its inhabitants being akin to animals in a cosmic zoo, observed, studied, but never contacted by civilizations far more advanced than ours. Although a humbling scenario, it does provide an explanation to our universe's silence. Lastly, we have the rare Earth hypothesis, suggesting that the conditions necessary for intelligent life are not as universal as we might think. Instead, this theory proposes that such conditions are so incredibly specific and intricate that they're incredibly scarce in the vast universe, making civilizations like ours the exception rather than the rule. All of these theories offer fascinating insights and possible answers, but none can conclusively solve the Fermi Paradox. Maybe the truth is an amalgamation of these theories, or perhaps it lies in a realm beyond the reach of our current understanding. While the silence of the universe may seem overwhelming, it by no means deters our pursuit for answers. Our primordial fascination with the stars will keep us looking up, listening, waiting, and constantly asking the age-old question, are we alone? In the vast cosmos, we are finding other worlds, some of which might be similar to our own. The universe is teeming with countless stars and planets, a testament to the infinite expanses of outer space. Among these celestial bodies, a particular type of planets piques our interest. These are known as exoplanets, mysterious worlds that orbit stars other than our own sun. To date, we have detected and cataloged over 4,000 of these exoplanets, an impressive figure that continues to grow with each day as our technology and understanding of the universe advance. Despite the vast distances that separate us from these distant worlds, we have developed several ingenious methods to detect them. One popular method we employ is the transit method. This involves a careful and methodical observation of a star's light, watching for minute dips in brightness. These dips occur when a planet orbiting that star passes in front of it, effectively blocking a fraction of its light. The simple yet effective method has been instrumental in identifying numerous exoplanets. Another technique, the radial velocity method, leverages the subtle interaction between a star and its orbiting planet. It detects the often imperceptible wobble of a star, a wobble caused by the gravitational pull of an orbiting planet. This method requires precision and patience, but it has proven to be a reliable way of finding exoplanets. Direct imaging is another method we use. It involves capturing an actual snapshot of the planet. However, this is currently the most challenging method due to the overwhelming brightness of the stars they orbit. The intense light often drowns out the comparatively dimmer planets, making this a tricky task. But locating an exoplanet is just the first step in a longer journey. The real challenge lies in determining whether or not these distant planets could potentially host life. This leads us to explore the concept of habitability. A multitude of factors contribute to a planet's potential for life, including its distance from its star, its size, mass, and composition, the presence of an atmosphere, and the critical resource of liquid water. Scientists, in their quest for extraterrestrial life, also look for what are known as biosignatures. These are specific gases like oxygen, methane, carbon dioxide, and water vapor that could possibly indicate biological activity on the planet. Each newly discovered exoplanet is painstakingly analyzed for these vital signs. Promising candidates that could potentially harbor life have already been discovered. For instance, there's Proxima b, the closest exoplanet to us, TRAPPIST-1e, a planet in a system with 7 Earth-sized planets, Kepler 186f. a planet located within the habitable zone of its star system. Every new discovery of an exoplanet, every promising biosignature detected, brings us one step closer to finding a second Earth. It's a journey of hope and discovery, and who knows, perhaps the day isn't too far when we might stumble upon an exoplanet teeming with life forms, forever changing our understanding of our place in the universe. We are not just passively waiting, we are actively listening for signals from other civilizations. This is the fundamental principle underpinning the search for extraterrestrial intelligence, widely known as SETI. Established during the early 1960s, SETI represents a worldwide consortium of distinguished scientists ardently working towards detecting potential signals of extraterrestrial origin. Operating a vast array of both radio and optical telescopes, SETI's primary objective is to extensively probe the universe, hoping to come across some evidence of intelligent life beyond Earth. The underlying concept of this remarkable project is quite straightforward. If there exists an alien civilization advanced enough, they could possibly be transmitting signals, either purposely or inadvertently, which we could potentially capture here on our planet, Earth. However, the vastness of the universe and the complexity of the task at hand cannot be understated. A suitable analogy would be akin to locating a tiny needle in a massive cosmic haystack. To make matters more challenging, this haystack spans nearly 14 billion light-years across, with the needle's location remaining obscure or perhaps even non-existent. Interference poses yet another formidable challenge. Natural celestial bodies such as pulsars and quasars emit radio waves, which can easily muddle our readings. Here on Earth, anthropogenic activities like broadcasting and telecommunications generate a torrent of noise, which can often render the task of distinguishing any potential alien signals incredibly difficult. The SETI project further grapples with the problem of deciding on the type of signals to search for. We tend to anticipate that an advanced civilization would resort to utilizing radio waves for communication, just as we do on Earth. However, this is purely based on our own technological progress. What if these extraterrestrial entities communicate using that are beyond our current comprehension? Despite the multitude of challenges and uncertainties, SETI continues its relentless pursuit. The potential implications of such a discovery are simply too momentous to disregard. If we are indeed fortunate to detect a signal originating from another civilization, it would undeniably be the most significant discovery in the chronicles of human history. This would irrevocably alter our perception of our position in this ever-expanding universe. The cosmos, with its deafening silence, might seem daunting, but we remain patient and persevering in our quest. Each new day ushers in renewed hope as we continue to survey the skies, fervently anticipating that elusive whisper from the stars, that subtle indication of a conversation occurring light years away. And who knows, maybe one day we'll hear something. Imagine sending a message into the cosmos, a cosmic hello from Earth. This is the core of interstellar communication, the daring task of broadcasting our existence to potential alien civilizations far beyond our known universe. It's akin to throwing a tiny letter encapsulated in a bottle into the unfathomable expanse of the cosmic sea, with a glimmer of hope that someone, somewhere, might discover it. The concept of interstellar communication is fundamentally based on the utilization of electromagnetic waves. We primarily use radio waves or lasers powerful enough to travel across the light years that separate us from other star systems residing in the vast universe. A message traveling this distance could carry an array of information, ranging from the fundamental principles of mathematics and physics that we adhere to the intricate details about our civilization's structure, cultural nuances, and our collective understanding of the universe we inhabit. However, the concept of interstellar communication is not without its challenges. One of the most prominent hurdles is the incomprehensible scale of the universe. Given the colossal distances involved, a message dispatched today might take thousands, if not millions of years to reach its intended recipients. This doesn't even account for the time it would take for a potential response to traverse the cosmic highways and make its way back to us. Moreover, we must grapple with the question of crafting our message. How do we construct a message that could be comprehended by a form of intelligence that is completely foreign to us? How do we encapsulate the essence of humanity, our collective history, the intricacies of our knowledge, in a way that could be understood despite the potential cultural and biological differences that might exist? And then, there's the risk associated with it. There are voices that caution against this endeavor, warning that sharing our existence with the cosmos could draw the attention of advanced civilizations that might not view us kindly. It could be seen as a cosmic gamble, a toss of the dice with stakes that could potentially threaten our very existence. However, despite these challenges and risks, the fascination of making contact, of bridging the cosmic divide, still remains an irresistible allure for many. What could be a more quintessentially human desire than the urge to reach out, to connect, to comprehend and be comprehended? The debate on whether we should reach out to the cosmos, whether we should risk it all, continues to be a contentious issue. But one thing is certain: our quest to understand our place in the universe, to answer the question of whether we truly are alone, continues to propel us forward. It pushes us beyond the limitations of knowledge and fosters our imagination. It's this pursuit, this insatiable curiosity, that has always defined us as a species. Whether we should reach out to the stars remains a debatable question. But one thing is certain: the quest to understand our place in the universe, to answer the question of whether we are alone, continues to drive us forward, pushing the boundaries of our knowledge and our imagination. What happens if we do find intelligent life out there? This question, while simple, unleashes a cascade of intricate implications and potential repercussions. The discovery of extraterrestrial life would be a pioneering move, fundamentally altering our perception of the universe. It would authenticate that we aren't alone, that our home planet, Earth, isn't the unique cradle harboring life. A revelation of such magnitude would have far-reaching impacts across multiple disciplines, from our scientific researches to our philosophical theories and even our religious beliefs. It would force a reevaluation of our position in the cosmos, compelling us to face the truth that we are merely a minor fraction of a much larger living universe. The notion that we are not unique, one among many, would challenge our sense of self, our identity as a species, and our understanding of our place in the grand scheme of things. The cosmos, once believed to be a cold, lifeless void, would be reimagined as a thriving, bustling ecosystem teeming with life. Beyond the scientific and philosophical connotations, there would also be complex social and moral issues to grapple with. How would we engage with these alien civilizations? What guidelines would we set up for establishing communication, for diplomatic relations, for resolving conflicts? Looking back on history, encounters between different cultures on Earth have not always ended optimistically. We would need to tread carefully to prevent our first encounter with extraterrestrial life from becoming a cosmic repeat of our past blunders, a space-age version of colonialism. Moreover, there's the intriguing question of what we could learn from these alien civilizations, especially those that are significantly older and more advanced. Then could they offer insights into technologies and knowledge beyond our wildest imagination? Could they aid in solving some of our most critical problems? Or the flip side, could they introduce us to new challenges and threats? Possibly the deepest implication would be the impact our sense of self. The discovery of alien life would compel a redefinition of what it means to be human. We no longer be the solitary, intelligent life forms in the universe, the exclusive progenitors of culture and civilization. Instead, we would become one among many, a single strand woven into the intricate tapestry of cosmic life. In essence, the search for extraterrestrial life is as much a quest for understanding ourselves as it is for understanding the cosmos. It is an exploration driven by curiosity, humility, and the thirst for knowledge. Regardless of the final outcome, the journey itself will inevitably result in change, growth, and evolution. The discovery of alien life would redefine our place in the cosmos. The pursuit of knowledge, the quest for understanding, will continue to push us towards new frontiers and shape our destiny in the grand theater of the universe. Our quest for alien contact is a journey of discovery, not just about the universe, but about ourselves. This pursuit is symbolically and practically akin to an epic quest that our species has embarked on, which is as significant as it is fascinating. And this quest has led us through the corridors of profound mathematical probabilities. As we've navigated the complexities of the Drake equation, we've had to grapple with the staggering implications of the vast numbers of potential civilizations within our own galaxy, the Milky Way. These calculations have revealed startling possibilities, prompting us to question the enigmatic Fermi Paradox. The paradox persists in its perplexity, continuously questioning why, given the high probability, we've yet to detect any signs of alien life. It has become a psychological mirror, reflecting our collective curiosity and craving for discovery. Beyond grappling with these equations and paradoxes, our quest has taken us on a cosmic journey to exoplanets far beyond our solar system. We've gone as far as our understanding and technology allow us, searching for biosignatures that could hint at life beyond our world. We've explored the universe's remote corners, from the promising candidates like Proxima b, TRAPPIST-1e, to Kepler 186f, keeping alive the hope that someone or something might be looking back at us. In our quest, we've enlisted the help of organizations like SETI, the search for extraterrestrial intelligence. They tirelessly scan the sky for signals from civilizations light years away, a task as daunting as it sounds. We've had to consider the challenges in this search. The vastness of space, the interference from natural and man-made sources, and the sheer uncertainty of what signals we should even be looking for. But this journey is about more than just finding ET. It's about understanding our place in the universe. It's about confronting the possibility that we are not alone, and the equally daunting possibility that we might be. It's about coming to terms with the profound implications of making contact with intelligent life beyond Earth and the philosophical, social, and ethical questions that it raises. In this journey, we've not only sought to understand the universe but also ourselves. Our curiosity, our fear, our ambition, our hope, all are mirrored in this quest. We've reflected upon what it means to be human as much as we have about the potential for life among the stars. Our understanding of ourselves and our place in the universe has been molded and expanded by the search for alien life. We may be alone in the universe, or we may not be. Either way, the quest for alien contact continues. Well now, that was a journey, wasn't it? From the farthest reaches of space to the hidden depths of our own planet. We've traveled through time, unearthing ancient mysteries and marveling at the unfolding of history. Every day, we strive to bring you the most fascinating facts and narratives from across the cosmos and right here at home. If you've enjoyed this expedition and you're hankering for more, do us a kindness and press that like button. It helps us continue our exploration and share it with folks like yourself. And if you haven't done so already, go ahead and hit subscribe. That way, you won't miss a moment of the adventure. We've got plenty more tales to tell, and we're just getting started. So stay tuned, y'all. The universe is vast and its stories are infinite. Until next time, keep looking up and stay curious.